Hello, this is Sean Skabinski with InterMet Systems. Now that everything is installed and configured, we can actually perform a flight. A flight consists of 7 overall basic steps, and we'll go over some of those later. The first step is to connect the decoder and system computer with the USB cable, and connect the audio cable to the decoder. We'll leave the audio cable unplugged from the ICOM ICR20 receiver at this time. Then, we'll start iMetOS in a real flight mode. Next, we'll activate the ICOM ICR20 receiver and scan for an available frequency. Once we have the available frequency, we'll activate the iMet-1 radio sonde, inflate the balloon, and prepare the flight train. Complete pre-flight baseline data entry and radio sonde check, and then confirm everything and release the balloon. After we've connected everything, excluding the audio cable from the receiver, we can start iMetOS in a real flight mode. First, we'll verify our radio sonde type. If it is incorrect, set it to the proper radio sonde type and restart iMetOS. I'm using an iMet-1AA radio sonde at this time, so my radio sonde type is set correctly. After verifying the radio sonde type, we'll check the base station GPS position for all zeros and for differential corrections to be off in the System Parameters 1 window. All of my base station GPS positions are 0 here, and differential corrections is off. Then we'll activate the receiver and scan for an available frequency. Now that we have chosen a frequency, we can activate the iMet-1 radio sonde on the frequency we have chosen. Here you'll hear the iMet-1 radio sonde activating and sending data. Here we hear data coming in on the receiver. At this point in time, I'll plug the audio cable into the receiver. I'll adjust the audio volume on the receiver to 75% and turn on AFC. With the audio cable plugged in and the receiver set, we should be receiving data from the radio sonde. We can verify that we are receiving data from the radio sonde by witnessing the record numbers go up and by seeing pressure, temperature, and humidity data changing. If you have an iMet-1AB radio sonde instead of the iMet-1AA in this case, pressure data will not read 0. Now I'm going to put the radio sonde in view of GPS and wait for radio sonde to acquire its GPS position. This usually takes about 2 minutes. We'll look for latitude, longitude, a reasonable altitude, north and east velocities, and an ascent rate. When the radio sonde first acquires GPS, it will likely be a 2D solution. This means that it will have latitude and longitude, but it will not have altitude yet. When this happens, altitude is usually in the range of -60 to +60 meters. In some cases, this may seem reasonable, but it is likely not. This is because GPS uses a reference datum, defined by WGS84, that does not exactly match mean sea level. The altitude that you will likely see initially is the difference between MSL and WGS84, called the geoid height. This is essentially what MSL altitude would be if WGS84 altitude is 0. Once the radio sonde acquires enough GPS satellites and calculates its 3D position, the altitude will be your measured MSL altitude. As we wait for the radio sonde to acquire its 3D GPS solution, other tasks may be completed, such as collecting the pre-flight information or preparing the flight train. For pre-flight information collection, I use InterMet Systems document number 200,790, the flight test form, to help me collect all relevant information pertaining to my flight. Once the radio sonde acquires a 3D solution, we could begin the pre-flight process. Here I have a 3D solution with latitude, longitude, a reasonable altitude, north, east, and ascent rates. To start pre-flight, I'll go to File, New. This brings up the pre-flight information screen. In order to make a flight, I must fill out a minimum of pressure, latitude, longitude, altitude, ascension number, and release number. While other items are technically not required, it's a good idea to fill them out if you can. I've collected my pre-flight information, so I will enter it. If you move to a new location, you could capture the radiosonde GPS position by pressing these three arrows. That will update your pre-flight position to be your radiosonde's current position. Now that I've got everything filled out, I can hit save. However, I generally want to wait to hit save until a few minutes prior to launch. This allows me to change values easily if conditions change, and it lessens the chance that iMetOS erroneously detects a balloon launch in the rare event that bad data is received. A few minutes prior to launch, I then hit save. The record number counter will reset to 0. iMetOS displays flight ready on the status bar. I'll wait at least 30 records to be received prior to launching the balloon. This helps iMetOS better determine the actual point of launch. Then, prior to release, I'll check the status of the radiosonde GPS again. Again, I'm looking for minor changes in latitude, longitude, altitude, north, east, and ascent rate. The altitude must be reasonable. Once I confirmed everything, I can launch the balloon. Once the sonde is in the air, there will be a slight delay until the flight clock starts. Once iMetOS has recognized the start of the flight clock will commence and the record numbers will reset again. You will notice the radiosonde moving on the plots, as well as rapidly changing data. At this point in time, there's nothing left to do except check on the status of the system from time to time. We can check our reports, our graphs, once they become available. We'll also check the receiver status, make sure we're getting a decent signal strength, and make sure that AFC is not continuously showing an arrow. When I have a graph open, as I move my cursor around, I could see the different values from the radiosonde being displayed in the window. I could also change my scale so I could zoom in at the start of my flight. Once the radiosonde passes the maximum altitude that I'm interested in, or the balloon bursts, or you lose the radiosonde signal, you may simply hit stop flight. iMetOS will generate its final reports and flight files. InterMet recommends that the flight be archived to preserve the data. At this point, you may then exit iMetOS and shut down the system.